they hit it. Hey, welcome to Coffee Compiler Club. Here today to talk about compilers and language runtimes and I don't know, boxing matches between people and whatever funny current events are going on in the world. And there are a lot of current events going on in the world. But coffee compilers be a little simpler than politics. Um, if somebody has something they want to start with, I'll do that, or I'll talk about chapter 17 in simple, which is done, and looking for a reviewer. And then I've started looking at chapter 18, which will be functions. And I think those will both be interesting.
I got a curious question, but I don't think you have time to answer the entire thing.
You have to, you already went this far, you must now ask it.
Yeah, it's the short. I just want to know like the short version of why would it take Clang and GCC so much time to compile something? Like, was it 200 or 20x slower? I don't remember,
You,
but
you,
that was a huge difference.
you had some big numbers. You know, these things depend on so many other things floating around that we could drill into it, but the obvious thing to do is you would go ask the profiler. Those compilers will all have per phase things. Like my recollection is you produce these source files which have like huge counts of modest repeated functions. And single large functions often trigger n squared or exponential behavior if they're machine generated, but little functions just go to like the bulk of things. And you could argue these guys just have so much overhead doing bulk output. I don't know. Profile. I have observed them being slow for many, many years. Why? Go profile.
Because when I looked at Tiny C compiler, it was like
Right,
milliseconds.
right. It's clear
Yeah.
you can do the job in milliseconds. Now, they might want to try to do some minimal optimization, which can add some weight. You know, it won't be TCC speeds, but the kind of numbers you were seeing are just like out of control. There's
Uh,
shit like, hey, we have a really bad hash function, and you have 2,000 functions all called function 99999 plus or minus a digit, and they just hash terribly. And suddenly they have, slow linked list implementations of hash functions and shit. I mean, I don't know. Actually, here's
yeah,
Arthur just showing up. We can go ask him
I
Clang.
don't want to peek under the covers or behind the curtains.
Well, right. Well, then you don't know. It's just acknowledge that it sucks and move on.
The other thing I was kind of curious about is there like a typical way that you like to generate like a machine code, like the actual bytes for like assembly?
When you say generate machine code, there's like a bunch of phases you go through, and that's like
Okay,
chapter
so
19,
more
20.
specifically, I mean, you're already done register allocation,
Yeah,
and you
okay.
just want to know what the opcode is for the move or the if statement or the
Right,
jump or whatever.
right. So I'll take machine versions of the Sea of Nodes IR. So the nodes in the Sea of Nodes will all be like idealized versions that represent generic adds and multiplies and if tests and the like. And I'll make a machine specific version. This is part of porting to a machine, which represents doing a related opcode. Um, and then that machine specific version will have a virtual call that says, go spit my encodings into a buffer.
The surprising thing about the virtual call, the reason why I didn't expect you to say that was uh, every machine would have a different number of registers. So, like, I can't imagine that working well with virtual memory. Well,
It, it,
I guess the actual data structure would be different, but
right. I mean, this has worked well for a very long time for a lot of architectures. C2 and Hotspot has like some huge count of ports, 17 or something ludicrous. It's all fine in terms of like it actually works, but maybe you're attributing the overhead or the complexity in the wrong place. When the
oh no, I
register
was just
out,
like I'd never done it, so I was just like wondering. Like I thought you would just
Well,
like look it up at a big table and then
so
or have a like a function that you call.
there's one thing that I think you're you're mixing together two concepts which are kept pretty distinct, which is like encoding and the actual availability of registers. Like the register allocator does all that work, and it has some fairly simple rules about what registers it can use and stuff like that. And that's all decided. And then you go into encoding, and the registers are already all decided when you're encoding.
Does that answer your question, Levo?
Yeah, mostly, but it was just like more
Yeah.
specifically, what bits do you set in the output? Because the
Okay.
three ways I thought was you either like add a number to something you look up at a table, the virtual call that way you mentioned, and I was like thinking maybe like have a bunch
Yeah.
of overloaded functions, and then you just pass in the parameters to that. But
More like a bunch of overloaded functions. Like x86 encodings are fairly intricate. Maybe there's a good word for it. So
yeah,
you've got these registers, they're just kept in a node as the output register number. So it's an integer field, it's a small int. Um, you go ask for the encoding on the guy, and the guy will go into like the specific node will go into the generic guy and say, I need a mod RM, and here's the mod pieces, but you have to tell me the RM bits. And then he goes into somebody else and says, turn the register into bits. I'm jamming into things. And he goes to some other shared x86 thing and says, give me the extension bits for the addressing mode and things like that. So a lot of these things will just be shared as a part of the x86 port. And the specific op, which is maybe an add to register from memory, will only throw in bits for the add instruction ops and hand out the register number he got from the register allocator to the common code. Will just have, I'm given a buffer, I'm given the mod RM bits, I'm given the register numbers, and I know how to now do an x86 encoding by whatever bit shuffle has to happen. If you're looking at like a risk five or a classic, any other risks have been around forever, the encodings are far simpler. And you can imagine an add op that's only going to be reg reg. He's going to go to the, I want to do a binary reg reg into, reg 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 encoding. Here's my base encoding bits. That'll be the add. And here's my def bit. And my node has inputs one and two, and I'll get my source regs from those two inputs. That'll be handed off to some piece of code that just does a bit shuffle and slams them together into a 32-bit op, throws them in the buffer, and you're done. The x86 version, a little more complicated, but that's the basic rule.
okay, yeah.
You're just going to merge bits together. The encoding time is custom special bits from the machine specific ops and registers from the register allocator, of which one or two are stored locally and others are stored on input nodes. And you hand them to somebody who does the bit shuffle and throws them down into a buffer.
Yeah,
Oh,
somehow my brain is very wired for risk. I tend to think about instructions as what is the op, what are the two source registers, what's the destination register.
right, right, right. And then there's load immediate, which doesn't have two source registers, but instead has an immediate encoding crap, which on RISC-V is the bits are just splattered all over the place. You have branch ops and compare and test and things. So you have some variety of ops that you're going to have to deal with. But yes,
See,
reg, reg, reg is the obvious.
when you say variety, it makes me like wonder why someone would want to do it as a virtual call. But it's I can't tell if you still like our virtual overloaded functions, or if you still, or if you do prefer overloaded functions to generate the actual, or to figure out the actual opcode.
The reason to do virtual is because you have a variety. So each node
Oh,
will tell you which variety it's doing
You mean a
via,
virtual call at compile time to
yeah,
assemble the instruction.
that's correct. Oh yeah, this is
Code
all at
generation.
compile time. Yeah.
Okay.
Yeah, yeah, yeah. This is not
So
at,
you translate your generic nodes into machine specific nodes. You go from a generic add or I don't even have an add op. I just have a binary operation generic node that has encompasses all binary ops, and then that generates a bunch of machine specific add immediate, multiply immediate, and all these like variants. And then each of those has an encode function, and you give it a buffer, and You call it, and all it does is add 32 bits onto the buffer, but it's going to be the correct 32 bits for that op based on how it register allocated and whatever inputs and options it sort of configured itself with.
And
I have
you
a
always think it's generic and portable until you go to port it.
yes. That's a different problem. I used to always say that, a compiler's portable after it's been ported at least 3 times. People come tell me, I have a portable compiler, and have you ported it? No, but I wrote it in portable style. No, it's not portable until it's been ported several times. And you beat all those bugs out. Fine. So, Lou, I got a question about you, and what is your issue with virtual calls here? There's something going on in your head versus my head about what they are.
It just seemed to me that because some operations has immediate values and others don't, that it would make more sense to have overloaded functions. And if you mess something up, you get an error, and like a compile time error. But if you have a virtual call, it sounds like it might become a runtime error, or you might not see it. Like
Yeah,
it just sounds. It was just. I typically choose overloaded functions when I can, just
right.
because it makes more sense to me. So
So
when you
there's
say
no
virtual,
runtime
that's
thing
like
here.
different.
This is all compile time. There's no runtime thing here ever. The compiler, I'm just structuring the compiler to handle a large variety of weird, strange encodings. And each individual guy knows something about his encoding, but the top level driver, which is walk all nodes, doesn't know anything about each individual node's encodings. So the top level driver can't say, pick this overload versus that overload. The top level driver just goes to each node in turn, node, and says, encode thyself, encode thyself, encode thyself. And that's a virtual call.
What if you get some kind of combination that it's not happy with? Like, when do you get the error?
There's all combinations are allowed or happy, or you have a bug, and then the bug just shows up as you've got a bad encoding or whatever. I mean, bugs are
Okay.
bugs, they happen.
Yeah, I just never done it, so I just wasn't sure what the ideal way is.
Do it a few
No,
times
it makes
and
sense. I'm just saying, like,
okay.
that's why I was like kind of confused.
Sure. It's one of these things where you use virtual calls enough, you kind of come to the places where they make sense and where they don't, and you choose to, reach for a virtual call or not accordingly. In
Should
my
I just write
head,
in Java and let the runtime pick?
that's the performance side of things. I'm just talking about like coding style. Like the coding style one is I have a very bushy, very shallow hierarchy of things. I have one machine op and he's got 200 weird machine instructions underneath it. It's very bushy. That's a virtual call layout. That's a layout that encourages a virtual call. Like a big switch would just be a big switch. Um, Overloads, you have to know already what the hell you're looking for, and then you're just using the name to be consistent or whatever. The overloaded name might as well be an unrelated name. It's just consistency. But you don't know in this encoding game. You only got the top level dude. In fact, the top level dude is driven by the compiler who doesn't even know if he's targeting a RISC-V or an ARM or an x86. He's just got a machine node. He doesn't have any clue what kind of machine he's targeting. Same for the register allocator. No clue what he's targeting. He just gets handed machine nodes and he asks each register asks each machine node, hey, what registers are you allowed? And then he allocates from there. So all these things the driver comes from, he has no clue what the target architecture is at all. So virtual call in that scenario.
How much can that layer be blinded from the machine nodes? Because
A
if it's
lot.
doing things like having dedicated floating point registers and dedicated integer
Yeah.
registers and a dedicated
No,
register for where the
those can
carry
all
bit
be
goes.
those can all be hidden. The register allocator does not care if your registers are dedicated to whatever or not. The things that the back end wants that are everybody has to acknowledge, you have to admit that you'll have registers. They can be none if there's no thing there. That you have to admit you have an encoding. I need a way to spill from one register to another. It can go through the stack. That's okay. You have to admit there's a stack. you have to admit there's a branch. I generally need a way to flip branches in case I want to relay out your blocks and have the branch go the other way. And then I'm sort of running out of things. I'll usually ask for a functional unit kind of thing with latencies for latency aware scheduling in a more robust setup. Like simple probably doesn't go there, but other setups will go there, the more complicated ones. But the set of things the core compiler needs here, you have an encoding, you have some registers, you have some inputs which are mapped to the registers, you have a spill op, you have a branch op, a generic I can branch to anywhere, I can flip a conditional branch. I'm running out of things here, there's not too many.
I
Okay,
think
so a
a
lot
little.
of that complexity got rolled up into this question of which registers are eligible for which instructions.
Yeah, so when you make a machine op, and I heard you, Levo, so I'll give you a second. But when you make a machine op, the machine op that you're making, so the piece of the portability that says I'm taking from ideal graph to x86, now I'm writing x86 specific things. He'll tell every instruction what registers are allowed for inputs and outputs. So that comes in as just a register mask. So some part of the porting definition, you acknowledge you have a collection of registers. The collections generally want to be fitting in a few longs. One long is easy, several longs is more annoying but doable. And that's just count of bits. So do you have 64 bits or less of registers, or you have 256 bits or less of named registers? You have some count of named registers. Yeah. So the machine op lists in a bit mask which registers are allowed, which are not, for all inputs and all outputs. That's part of the machine encoding.
And that's also where you capture things like if I write to AEX that A got stomped.
Yeah, if you're crushing registers, that's part of that too. Yeah. So the normal way I do that is I have projection nodes that never get flipped that follow a machine node. The projection tells you what value slice is usually numbered from 0, 0, 1, 2, 3, 4, 5 or something. The machine op will say, if you want to know what projection number 3 does, here's the register he kills, and he has to supply that. And there's defaults that are empty for everybody, so most instructions don't need that one. But if I'm writing a CAS op and it's going to blow the flags and it's going to blow something else and write weird things, you can totally write it in the machine ops generically. So yeah, these things are all fairly well separable.
Seems like the right rug to sweep that complexity under.
Exactly. Yes, you have to sweep it up. It's complicated. You have to put it somewhere. So the general rule for the allocator is he says a node produces a set of registers and has a set of inputs, and I can ask what they produce as the set. And then perhaps a node has some outputs that he sets as he sets more than one and or kills. He can set multiples or kills multiples. And that's all the allocator really goes on.
So I remember you saying that before that a register allocation uses a lot of heuristics, and it sounds like you're not doing a machine or like a target specific heuristic. It's like it's all general.
Yeah. So C2
Okay.
does very general. That being said, there are x86 is so popular, and the different generations go through these different waves of what the expense for using different register things. There are a few things thrown in to help x86 from older generations. Now I left, Sun whatever 20 years ago, so I don't know what they've done. I'm not counting SIMD here either, just the general purpose registers. There are a few things going on, and one of them was like, don't reuse the same register over and over again, which that heuristic may have gone away because register renaming hides it. There was at least one generation where even with register renaming, it cost an extra clock to use the same register again and again because the renaming added a clock somewhere and you had to have it or something. There was another heuristic that says pick the low numbered registers first because they encode tighter and you got smaller iCache footprint out of your register sets. Um,
Yeah.
mostly these things are really generic. Yeah.
Oh, interesting. Yeah.
Yeah, x86 these days, I mean, a long time now is, I mean, the encoding is bizarre and a bitch, but the actual registers can mostly be used anywhere for anything. It's essentially 2 or 3 address risk. Specific to x86, you will get add to memory and add from memory kind of ops. But that goes in the x86 port layer where the guy who's doing the porting says, I have an add. Where did it come from? Oh, it came from a load. Well, let's just see if I can use an add with load op here. And that piece, like the register allocator doesn't care, doesn't see that piece. The encoded instruction after that has extra inputs that'll be the address base and offset registers, but that's just normal registers from the allocator's point of view. I guess store to memory, load op store to memory has a weird anti-dependence bug that you have to check for. But again, that's the x86 problem. And the allocator doesn't care. All right, any more how to go cogen questions? I was going to do chapter 17, chapter 18, simple, but I mean, that's just
Let's do
me
it. Let's do it.
doing random stuff. Um, let me, let me bring up, let me change my font.
I wish my compiler classes in school focused more on code generation.
Oh, good, because I hear a lot of people bitching about classes that focused on parsing, like the Dragon Book. Okay, the Dragon Book parses everything on the planet. Okay, fine, but suck,
Yes.
cogen. What
My
the
compiler
hell?
classes spent a lot of time on parsing, and then we just sort of like wrote little interpreters
Oh,
for our SSA. And
yeah,
I was like,
I
great, but
had
at some point I would like to be able to write instructions the machine can run.
I had parsing in compilers, and at some point somebody figured out that, you had to be in the grad level to get the actual compiler courses that you did CodeGen. And then, 20, 30 years later, I was like, why would I ever do any of these weird parsers? I used them in grad school several times and once outside of grad school, and they were always a bitch to use. Whereas a recursive percent parser was so fucking easy and covered all these languages, I never looked back. Fine.
Well,
Uh,
I've mentioned this many times before, but the Indiana University course that I started out with does not waste all its time messing around with parsers.
most boring part of theoretically well understood and perfectly obvious theory side and the
Yeah.
smallest piece of a compiler.
Yeah. Yeah, they do this nanopass thing and they get you compiling a simple program from end to end from the first sort of
Yeah.
exercise. I think it's like the third class. You've already got a compiler that will like add 2 ints or something, and that's all it does. But you start there and you then build out from it, and it's
Build out
pretty
from
nice.
there. Yeah.
The only thing is that it's it's all nanopass based, so it's sort of like a different compiler philosophy, which
I get it.
uh, only gets you so far, I'd say, from my experience.
You're teaching undergrads, I assume. I'm
Uh, I think it was. I'm not sure. It might have been a grad
maybe
course. I
interesting.
don't know. It was
Okay. At
online. I
some
just took
point,
it.
if you're doing undergrads and you're trying to teach high level undergrads, you still got to live with the timing and constraints of how good a coder they are. And then I don't
Yeah,
know.
yeah. I don't know.
The problem isn't that undergrads are good or bad at coding. It is that they are vastly inconsistent with each other.
Yes. Yes. I've definitely seen this. And I don't know how you teach against that. And I work and see a bunch of academics on a regular basis, not a regular, semi-regular basis, and talk to them, and they always have this problem. Wild inconsistency. What do you do? I don't know. Teach or move the lower half, whatever lower means here, along to a different career, or more time to get both more mature and more mature coding. But yeah, there's wild inconsistencies in how much people. Yeah, I saw
So
it
at
as
least
a
the way
guy
it was
doing
done in
hiring
my
too.
day was there was basically two courses. There was one set of coursework to pass the class and a different set of coursework to get an A.
Yeah,
And it
Adrian.
was just like, you don't have to do most of the work.
Oh, yeah. I claim.
I feel like that's gone away now that
Okay.
basically every course is A fail.
Oh, Huh. I definitely think that there's you learn by doing, and you just have to do a bunch. And people who come in sharper, knowing what's going on, probably picked it up earlier and have done a lot more doing as well. And they're not just taking the course because everyone's a programmer today and we're trying to, get an easy job.
In my intro to Java class, I was sitting between two kids. One had never written a line of code before
Mm,
and was very confused by things like you have to compile between changing the code and running it again.
mhm.
And on the other side was someone who was writing sprite-based Legend of Zelda-like games in class.
Yes, in his bored spare time. There you go.
These two students were in the same class because there was no way for the one kid to test out of it, and
Right. Yeah, I
it's
don't know what
hard.
to do about it either. You'd like to be able to, that one I'll be able to test out of. I think that one makes sense. But testing out was always a weird thing. I tested out of a bunch of classes at Texas A&M, but there's definitely some inconsistencies going on there where if you were good at testing versus good at whatever you were being tested on, fine. I don't know. Um, Syntactic sugar. I'm going to steer back to syntactic sugar for a little bit because I want to talk to people about mutability because that's the interesting one. So I'm going to hit these other things first because they're easy. Argument, pre-post increment. Operator sign. I don't think there's anything surprising here.
Can you increase the font a little
I
bit?
did, and I can increase it yet again. Da, 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 da. More or less, well, not less, more or not more. No one says anything. I'm going to go
Looks
more
fine to
again.
me.
That's readable,
That's
I think.
okay?
Yeah.
Okay. So what happens here? Emacs doesn't like his font size. There we go. Good enough.
Mm.
Okay.
What is
So,
what is the thing about allow pre-increment for identifiers only? Just out of curiosity.
say again, Matt, your sound was low.
What is that thing about allows pre-increment for identifiers only?
Oh, that's because I didn't want to deal with this. Yeah. Because it requires some more gruesome hacks in the parser. So I just bailed and
Ah,
said, "Ooh, I'm not
interesting.
trying to make an official real for real language." So
Got
the
it.
leading minus has issues with semantic aliasing, this kind of crappy things
Fair
where I
enough.
need more look ahead, and then I have to evaluate the entire expression here. Let's say struct here, but this is some arbitrarily complicated expression ending in a dot field, which led to some funny cases that can be dealt with, and I didn't want to, so I bailed.
What is it that you think pre and post increment helps you think that would be harder to think with z equal plus equals one?
I actually,
It's just the shorter form.
yeah,
Like there's a long history for me, but that turns into a long history for C and C trainee programmers forever and a day. And the long history is that everyone does memcopy by a lot, and plus plus minus minus on the pointer increments were directly using the hardware's increment decrement ops as part of their moving memory. So it was you knew the C compiler was going to emit the faster memcopy code, which you really wanted it to do.
ink and deck, although That's also the reason I prefer pre-increment and pre-decrement, because it reads more naturally to me as in increment I, increment array at index, or decrement array at index. Like I literally read this increment and decrement. So it just reads like very direct way of saying, I don't want to say read A of I, add one, store to A of I. I just want to say increment II. So it's more direct this way.
Or minus, oops, or minus equals one. The other, the other obvious choice that Aaron's saying is this one. And I'm with Matt. One of the two, either pre or post inc or dinc, reads more easily for me. And in fact, there were in the beginning, there were only pre-increment and only post-increment hardware ops. And the C language ended up adding both versions in both directions and just, working out in the compiler, and no one really cared. But it's easier to read. Now I like plus plus specifically in for loops. So, here's my plus plus right here in my for loops, in my for loop. And that to me.
And you think I plus equals 1 right in that spot is not as pretty.
Yeah, it's not as easy to read. I actually have to go parse it out more. Why did you do this even? Where here, the intent is clear. Stride one, complete access, access everything in order, one after another. I know exactly what you're doing here.
And every time I read I plus plus, I have to question myself why someone didn't write plus plus I. So,
Oh, I see. Yeah, right. Well, I don't care. In this context, this reads a little worse for me for the long history of plus plus being a post increment, being the early hardware had this op, but not the other one.
Gene's talking in the background telling me on the deck processor you wrote I plus plus instead.
Right. Fine. Okay. So the plus plus one didn't run into my issue, so I can put it in either side, but the minus minus did. So I bailed on it for the moment, other than for like this, like local variables. So here, for loops have an interesting non-increment issue, and that's the effective expansion of a for loop here is roughly open a brace so that you get a private scope for the index variable in init. Then you do the init logic. Then you do some while test effectively. Then you got the body. Then you got the next code. That's roughly the expansion. The problem here is that when I look at the expansion and I look at the for loop, the expansion says read the init, and the for loop says read the init because that's the order, left to right. I'm just parsing in order. This is the parser now. So he coughs up the bracing next, and he puts the init in. And he says test. Okay, he puts the while loop and throws the test in. Then he sees the next code, but he can't put the next code into the graph. He has to decide what to do with the next code off to this side. This is where an AST would be more beneficial than going straight to SSA. He has to put the next code off to the side, parse the body, then throw the next code in. And I went back and forth like three different times before I finally settled on I do a fast, cheap, balanced paren parsing of next and just mark the endpoints of the next code and don't actually parse it into nodes or correctness or anything. Then I do the body, then I go back and parse. So I parse out of order. I skip a hole in the source code, parse the body, and go back. But I tried it, like I said, like 3 different times, and they all had their issues with making life more or less complicated.
The other issue is that most languages have severe limitations on init and next. So, for example, Java, I think you can declare something in the init, but you can only declare something of one type, so you can't have it's all these weird limitations.
You have exactly one type here, but you can do multiple
Right.
variables.
You can't just put braces there and put an arbitrary block?
Nope.
Well, the braces in the simple parser, you could put a brace here, but the scope ends. So then,
and then you wouldn't actually init anything because it would go away at the end of the
it'd go
scope.
away. Yeah.
And same thing for the next, like you can do certain combinations of things, but not others. So the rules are actually fairly complex just to keep the compiler simpler, which
Yeah.
always seems to me to be the wrong answer.
The next
I mean, it
code
depends how
for
much time you have. You have to get the compiler out the door and fix
well,
things
the
No,
other
what I'm
ones just
later.
saying
have
is you've got 10 million people using the compiler and 3 people writing it, right? Like whose time, when you do the big O on that, the 3 people writing it, it doesn't freaking matter how much time it takes for them to make it easier for the 10 million because the
only
payoff is going to be
That's
huge.
only if the
actually
million people
backwards
only if the
because
million people are paying for the three.
if those 3 people can't deliver, then all 10 million people are waiting.
That's
Of
right.
course. Of
And
course.
the 10 million people aren't paying. They never pay. This is like tools. The economics of the compilers make no sense. A million
I
people are waiting
mean,
for the tool
Yes,
to
Borland
compare
C
to
was
I
a
it.
was setting
thing. Borland
aside
made a
the
lot of money
economics
selling C
for the moment.
compilers.
Not in forever and a day. You go look at the economics of tool generation in the programming land. It's really sad. Fine. But yes, I too have the same limitations. My next here has to well, it's an expression. It's an expression. I think I could survive anything you want in
Yeah. Somehow I
curly.
usually think of the goal as not a million people using your compiler and a million people paying, but a million people using your compiler and 1,000 people paying.
If 1,000 people paid, you could probably get more stuff going on. Yeah, be nice. That's probably the right ratios. How many people pay for IntelliJ versus take the community version? I'm sure it's pretty bad. Fine. Anyhow,
Hey,
I'm not getting paid for this, so
Cameron, can you I don't show you by the net next because I can't see they won't show me the video. You
oh, you
clarify
can't
that?
see the video?
He is
Well,
talking
because
about the
it thinks I'm
three
driving, but
blocks
I'm
in a
talking.
for statement.
No, there's no button
Oh.
that says I'm not driving, so yeah, it won't show me.
We're talking about a for loop expansion. So simple, the language picks up a for loop, a C style for loop.
Yep.
For has an init, a test, a next, and a body. What are the limits on the init, test, and next? One of them on the init side is you can only init a single typed variable. And what can you put in the next section? Normally you think of it as an expression like I++. I often do linked listy things. Next equals, pointer.next in the next part of the for loop. But can you put anything you want there? What kind of declare new variables? What can you do? What does it make sense to do? In my parser, I just gave up and said parse an expression. Well, parsing an expression turns into I can put curlies and parse a block. You can put a block in a next statement, anything you want. Might as well put
I
that in the
gotta
body, but
One of
I
the
gotta
side
make
effects
fun
of
of
our
C for
syntax
a
allows you to.
second.
okay, like 3 people talked at once here.
C, their answer is comma operator. I just have to
Yes.
make fun of that. That
Yeah.
was not great.
No, but it's not a terrible answer either.
I use it sometimes in macros. For that
Yeah.
time, those times it's great.
Yeah, and things I'm doing with ecstasy, I would love if Java had a comma operator all the time.
So the problem with the comma operator though is that it is involved with the type check as well. So in C it has side effects that can be ugly. So
It's the goal. The goal of the comma operator, as far as I'm concerned, is to have side effects and to let you mush a bunch of side effects together and declare it a single expression.
yes. Yeah, so yes, if you're addicted to it, you're
No,
addicted
just
to it.
for generating code. Because if I'm outside of generating code, I use it very, very rarely. It happens. It's very rare. Generating sequences of ops, the macro expansion, just like Leibniz and macros expansion, that it's really useful because it just lets you glom two things together that you have no clue what they are. And if I couldn't glom them together, but I had to because of the situation, then I have to know what they are, and that makes the problem hugely more complicated. So it has a purpose. It's, as far as I'm concerned, it's for basically DSLs, DSL written in C.
Well, I heard that a lot of people used to make coverage tools based off of like using defines on ifs, whiles, and all that.
Yeah, exactly. You know, there are things you could do there.
So in Clojure, you can put in any kind of expression absolutely anywhere, including a do block, which is basically like a comma operator. And you can just structure your code as stupidly as you want, and that's fine.
There you go. Okay.
I got another question. Yeah, I
Yeah.
thought I was needed there, but I wasn't. But anyway, like what I thought was confusing about in C about pre-increment and post-increment was the pre and post part. Is there? I mean, if you just picked one, which one would you pick in your language?
Oh, I was explaining before you came on. These things came in because the very early hardware, the hardware manufacturers realized that memcopy was everyone did memcopy all the time, and you needed some sort of support for memcopy. And the generic easy support for memcopy is load at register and then increment the register after the load, and then store at register, except decrement the register and store at it. And those two ops let you write a memcopy, a move a byte, followed by a decrement and branch op. And suddenly in 2 or 3 ops, you had a memcopy, but you had the generic version of it that you could do only loadings and only storings and fills and backwards moves and forward moves and all different things. But you needed a load with an increment and a store with a pre-decrement. So then the C guys said, we'll make an op for that in syntax in the language so you get that hardware instruction because it's crucial that all your memcopy variants run fast. So
I'd say they're dual. Increment, pre-increment was, I'm sorry, post-increment was for load, and pre-increment was for store.
Yeah.
Okay.
But if you were doing backwards things, so I'm sorry, if you're going backwards, you needed the pre-decrement, and if you're going forwards, you needed the post-increment for both loads and stores.
Oh yeah. Okay. Oh, okay. I see.
So you needed just the pre-dec or just the post-inc, but not the pre-inc, not the post-dec. Then completionism came in and they gave you all directions and the compiler just sorts it out. Hardware got faster. No one cared to count those ops anymore. You just
in
did
C++,
them.
when you do use pre-increment very often for iterators, I think 99.9% of the code only needs pre-increment and pre-decrement. And you almost never want post, because it's just weird and confusing semantics that you return the old value after you modify. There is like 0.1 examples when you would use post, but most of the time you only want pre.
Well, right. I think the real, in my head, the real story here is that doesn't matter what order I highlighted I++. It doesn't matter what order it happens because no one's looking at the result of the expression. So I don't care. I want to add 1 to I, but I don't care whether the result expression returns me the pre or the post because I'm not using it.
Yeah, if you discard it, then it doesn't matter. Except
Doesn't
again,
matter.
for me, readability kind of is an argument. I really prefer to read increment I as opposed to I increment. So
Yeah.
it just reads better in English for me.
Okay. Yeah, like I'm saying, I'm here for historical reasons, not for English language, but because I grew up on hardware where that difference made a difference. And it hasn't made a difference in 30 years, but
okay. So now that's 30 years later, what can you get by with? Can you just get by with one? And if so, which one would it be?
I claim I could get by with one, but I don't need to. So why not just support both?
In C++, you would go with pre because you don't want to actually have this return and hold on to the old value side effect because this could cause performance loss or complicated things like iterators.
It's not going to cause any performance loss.
For iterators, yes, because it's a side effect. The function may be opaque, it may not be inlined, and the compiler will not know how to optimize it. I'm not talking about integers. I'm talking about class objects, which could be iterators. An iterator could be advancing through memory or through disk. You may have very opaque objects.
You're talking about operator plus.
Yes.
Yes.
So if I have to choose one, yeah, but if I have to choose one operator, that was the question. Only pre-increment semantics or only post, I would choose pre. Because you can build post on top of pre, but you can't do the other way around. Without losing performance for all arbitrary cases.
All right. So the major caveat here is this is an operator, overloaded operator being called with an arbitrarily complicated operator iterator, an
Yes,
iterator.
and again, to me, if you are using pre-increment to move in loops, you want this. Because there is no reason if you are going for a database table to have a different syntax for this. So you need a plus plus to always means go further in my loop. Because I do not want to have million different loop constructs because I have personal feelings about operator overloading. I want simple code, that's why I want to have consistent code, that's why I want operator overloading. That's the simplest way. I'm completely unsympathetic to people who complain about operator overloading. I don't think they know what they are talking about.
Okay. I've only been burned by it a few times. But I don't try to do increment plus pluses on complicated iterators either. But maybe somebody does, and then it makes sense. And what you just said makes sense.
So just make sure I remember from my C days, I plus plus means give me the value of I and then increment it after I get that value. So I get
That's
the
right. That's right.
plus I means increment it first and give you the
Right.
value.
And what Matt's just saying is if it's an overloaded operator and the plus plus is really a function call doing something horribly complicated and returning you a structure, which is the iterator's main body, which is either the pre or the post version. If you do the post increment, the expectation is you needed the post version of the iterator, but you got returned to the pre version. Suddenly you have two copies of the iterator alive at the same time. If that iterator is not fully in line by the compiler, he has to make it exist as opposed to just declaring it dead, looking, doing a little flow analysis, deciding the pre-version's dead and throwing it away and never bothering. But if he can't inline it, he can't make it go away. It's a function call. It says plus plus, it's really a function call. Then you end up with two versions, and the compiler has to have them both alive, and that does burn a lot of overhead. That one is correct there.
By the way, just as a curious fact, ARM assembly has all four versions. So in ARM assembly, you have post-indexing, pre-indexing, and the same for whether you increase or not, whether you increase or decrease. So all four versions, pre-decrement, post-decrement, pre-decrement, post-decrement, and the same for the increment. Sorry, you can both increment before and after, and you can decrement before and after in the ARM assembly. So basically, all different versions have separate instructions encoding.
Okay.
Which is kind of curiosity.
Sure.
So
yeah,
that's
Cameron, I don't want to go there with the comma operator on the initializer, but if I did the comma operator on the initializer, he'd throw one in the chat here, which I probably should throw into the doc or something.
Yeah, and just to be clear, that's not a comma operator any more than semicolon in C is a semicolon operator.
Well, you're separating two different declarations.
Yes.
Yeah, okay, yeah, right.
I just wanted to be clear, it's not an operator. It
yes,
does not
so
have...
some unrelated list of declarations all buried within some sort of declaration space without using a semicolon.
Well, it is some sort of a thing because it's kind of like you can get the essence of a comma operator by having a function which takes a bunch of arguments and just returns the last argument.
Oh, but that's not what I'm
that's not what he's doing here.
I just wanted to be clear, that's explicitly what I'm not doing.
Yeah, he's making declarations.
So think of it as what Guy Steele refers to as a separator as opposed to an operator.
Yeah, it's not an operator. Yeah. I'm not being precise with the term operator, and you are.
Although, for what it's worth, when you define language semantics, you often introduce semicolon as a sequencing operator. It's called sequencing operator because A semicolon B has to be executed in the sequence. You first want side effects of A before you execute B, because B relies on this as a precondition. It's all operators. You just cannot overload all of them.
So an interesting side note, I was searching for a complicated example and I couldn't find any because 90% of our for loops are of the colon variety, the iteration variety.
Yeah.
Yeah, that's actually the related question. Do you really need the full generality of the for loop syntax? Because I think you claim you often don't. You often just want to traverse entire collection Not like
I
start in the middle and then go 3/4 or
I
something
looked
like that.
through a bunch of my code bases and I counted and I got 50% could not be done with a colon operator. It's a very common for me. And if I don't have a colon, I don't have a for loop, I would have to write the
While
full
loop.
on while loop kind of thing, and it just would look
Yeah.
a lot uglier.
So let
Do
me
you have like typical
clarify
example?
something, Matt, if you don't mind. One of the interesting things I'm noticing is on the application level code, we have none of the three-part for loops. They're all colon based.
Sure.
And on the system stuff, it's about 75-25.
Sure.
So
75,
So
25
if
full
Cliff
base.
is saying 50-50, I totally believe it because he's like, I'm getting every last freaking clock cycle here.
It's part of the expression looks
I,
better.
that wasn't, yeah, and I wasn't poking at you, Cliff.
No. But
I
I'm not talking
totally
about, it's not
understand.
performance here. I'm not reaching for this for performance. I'm reaching for the three-part thing because that's how the expression goes that just looks easier to
Do you
understand.
have some typical example that is really screaming for loop?
So as
And
soon
it
as I
cannot be
need
done.
to update an array, I need a left-hand side with an array sub I. And if I'm doing a filtered update, I'm copying from A to B, filtering as I go. Oh, I can roll the filter guy. Those just always look uglier to me than just writing the for loop. As soon as I have two arrays, I'm looking for between two of them source and writing to one and filtering as I go. Suddenly it's like,
So something that with a zip basically. No good
yeah,
syntax for
maybe.
zip.
Of course, I don't have an example handy without going to look here, and then,
I think you're probably looking, but I'm going to throw in a question real quick. What does I plus equals 1 do in C? It's give me back I after incrementing or before?
no, the plus equal gives you always afterwards, which is inconsistent with plus plus. Cameron dropped and rejoined. Here we go. What was I doing here?
I don't know if it matters, but most of my loops are for loops. I barely touch a while, and I never use do while. And every once in a while, I'll use two parameters on the for loop. But I think 95% of my code is just the one integer.
This is a bad example, Matt, but this kind of thing happens to me. So I don't have a good example to show off here, but I'm basically saying walk one of the arrays completion, walk B and C completely, test a predicate based on the probably based on just the B and C.
Right, fair enough. So some kind of zip operation is missing, basically.
Yeah, I want to right the more yes, and in here I don't want to have another semantically different, syntactically different thing that for every possible case of these. So I just want to reach for the loop over it. The induction variables, the index variables only have lifetime for this loop. At least one of them generally walks the entire loop. One of them might be short, might not. It might not need a J, kind of varies.
I wonder how many different cases are these like this in other than the zip or going through multiple collections
Cameron, you
at
want
the
to
same
write
time.
your comments in the Google Docs, and I can switch to the docs if we're looking at things here. You're showing up
Sorry.
examples that you have. Yeah, I do the +2 things, even odd pairs and stuff from time to time. That happens as well.
Yeah, I was just listing some misfits, but yeah, I could probably pull up the docs.
They're on the docs.
They're in the docs. Let me switch to the docs for a second because I can go hunt for actual ones I've got lying around as well, but that'll just be, here's
Cliff,
more examples where it's not.
In your example, I normally need the J after the loop, so I never have it in the for loop. So that's probably why I
and you're correct there. There are several times where I need what I actually ended up with in the end. So yes.
It's almost always for me, and that was one of the inspirations for break and on continue and my on statements.
I'll throw this in here, and I'll go with Levo. I'll make the modification here. I actually usually do the initialization inside anyhow. so everyone knows, but then I use J here because that's the size of the array A in the
A
end.
little bit zoom on the
Just a second. Yes. Good enough?
yeah.
Let me the length here, see if I can't shrink anything else here. You know what I can do? The other option is I can increase the font,
Yeah, that would
and that
probably
would
be better.
reclaim some space here. Hang on, let's try format text, size, increase, Control Shift plus. Control Shift. That did not work. How about this? That worked. Okay, maybe the font's all bigger, but the header shade smaller, so maybe we get more visibility. Yeah, right. Awesome. Right. So Cameron, your examples are, yes, one of several kinds of things where I'm looking at things. Your path question equal parent with no next is a little more weird, but I certainly have things where I do with for loops where I do
Yeah,
walking here.
for the bytes, boundary bytes, I think I would just write a while loop. The iteration by offset by 2, that would be just a strided view over a collection. So again, it depends how many abstractions you have over your collections. If you have something like view every second element of the collection with the stride, then it's not a problem. If you have a zip, then multiple collections are not a problem. So this could be a sign of missing abstractions, but of course there's always some kind of balance what abstractions you can desugar efficiently and not, I suppose.
Yeah, it's the narrow waist problem. I don't know if you guys have read that article.
No, I don't recall it. So here's one where the iterator isn't over any expressed condition. I have a tree, an abstract syntax tree, and I'm at the leaf or somewhere in the middle, and I want to walk to the root looking for something, but I don't have a separate condition per se, or I don't have a separate collection per se for every part of the tree as a tree. Every path from any leaf to the root could be considered a collection, which is what I'm considering here, without writing a collection iterator per se.
Yeah, either a while loop or again, that could be a matter of the next function setting the AST to AST parent.
So Adrian says, "What might as well be a while loop?" You're saying, well, I disagree, but it could be. So to do a while loop, it's AST equals this, and then while AST is not null, and then oops, the things if AST dot predicate.
And of course, for something like this, you could have just a find algorithm with the predicate.
So I can't hear you on my typing because I had to switch keyboards again. So here's the while loop version. It's it's like twice as long or 50% longer, and I claim it doesn't provide me at least with any more readability in a for loop. I clearly want to
Fair enough.
have an iterator of the moment. It goes away at the end of the expression. It doesn't have lifetime issues. I'm going to walk all of something, and then I'll break out with an if return.
Fair enough. I mean, to me, it still is really a missing abstraction because, I mean, not null is your terminator condition. So in C++, that will be a sentinel of the range. AST, that's AST parent. That's again missing abstraction for the common next or advancing the iterator. Because you are really just advancing your iterator here. It just happens to be over AST. But
right.
Again, there is no reason to have a different syntax for it.
Well, the issue here is that I could make an iterator to do this and then call it, but I claim that wouldn't be any more clear than what I just wrote because I'd have to go understand what that iterator was doing. Here in the one line, I understand what the iterator is and how it works. If I make a private custom AST iterator that does leaf to root walkings, and I might need 3 different varieties of these iterators.
And to be fair, at something like this, I would be probably using a find algorithm. Because I can see I am basically traversing something when I have a starting condition, I have initial condition,
Yeah.
I have an advanced operation, and I have a predicate that you even literally called predicate. And then you return something you've tested. So that's basically stood find algorithm.
Yeah, it's a
And
find.
I would claim that's even clearer than writing a dedicated for loop.
There are also versions of this where the return is a break, and I need the I need the AST
So you would want to
outside.
write what? For AST in AST.ancestry? If you're doing the for each version?
And then there's Aaron's trying to say, I have a colon syntax of some kind, but now I want to say this, and I want the iterator
This dot
that is
ancestors.
ancestors, like this. And the only point I'm making here is that I'd have to go implement this ancestors and go understand it when I wrote the code, whereas I have it above in one line. Literally one line gives me the entire iterator I'm looking for without having to go far afield to go find it. This is no shorter than AST.predicate return found it. I claim that was no savings in mental abstraction.
Just to me, it's kind of the more complex use case that shouldn't necessarily govern the common use case, because 99% of the time I just see people traversing collections, right, arrays, and there's so many things you can get wrong in this loop. I mean, off by one errors, or traversing
we just had this discussion. Half of my loops look like this, not 99%.
Well, in your case, but the code I'm encountering.
Cameron just said the same thing in his cases as well. Not half, but he was saying 25%, a fair number.
In systems code, it tends to be the more systemy you get, the much higher the percentage is, and the more application-y, the less the percentage.
Which is 25, which is 75, since I can't see the code. Is it which one's which?
Cameron, that would be you.
So in our application code, we are pretty much 100% colon style collection based iteration based fors. In the system code, we're about 25% 3-part fors and about.
I really wonder what is it. It must be something about Java, because in C and C++,
this isn't Java.
Which are commonly used in, I think it is, because in C and C++, including Linux kernel, which is as systemcy as it gets, most of the cases RB will be a for loop of an entire array, or you will write while loops. And while loops are pretty common in Linux kernel, no one complains.
Right. Yeah, and I just said we're 75% iteration based, even in the system code, at 25% 3-part for.
Yeah, so that's different than in Linux kernel, I would say.
But I claim that's a cultural taking on the Linux kernel folks to say, hey, use a while loop. If you can't use a for with a colon, use a while loop. And this is not
I think people just gravitated. There was no coding standard in Linux kernel for a very long time. So I think people gravitated towards naturally.
There were very definitely coding standards on Linux kernel, because I worked with Linux kernel engineers and I got beaten on for not coding standard. Oh, absolutely, there were coding standards for a long time. You better believe it. But that's separate. The while loop thing, I don't know that there was a standard or not, or any push one or another.
I don't think anyone pushed for the while versus for.
Okay, for me, I gravitated to, in the one line, I have the iterator. I can understand what the iterator does. Done, walking away, moving on to what the loop's trying to do while it's iterating.
So now let's talk about do while, my favorite.
Oh my God. You can shoot do while.
But they should go to the same thing. So comma, not comma.
No.
Do while is banned in my code base. I will never use that.
I mean, in my life, I've used like 3 do whiles that were more expressly done as a do while rather than as a while loop. Fine.
So the both styles do the sugar to the same thing, yes?
I do like do while, so.
Do while.
It's very rarely used, but
Well,
it's
isn't there a way to make this thing format on me here?
but the big problem with do while in most languages is the while can't refer to any of the stuff that's in scope in the do, which just makes absolutely no sense whatsoever.
Yeah, that's
Oh, yes.
100% of why I never use it.
That, yeah.
It's so useless.
Like if I have to declare the stuff outside of the loop anyway, what's the point? I'll just use
Yeah.
the for or whatever. Yeah.
Maybe this looks better. Whatever. All right, I made an effort to code color. I don't know if it did any good. Well, so we have a difference of opinions. We are agreeing to disagree. And you're welcome to write all the while loops you want. And I might someday implement the other iterator in simple or over arrays. There's no collections in simple except for arrays. And then to get a collection where you use this kind of thing, you kind of got to get to operator overloading or some sort of syntactic sugar for calling out the iterator functions. And actually, there's a lot more work on the compiler to make these collections go fast because you have to prove the iterator went dead after the loop and stuff. There's a bunch of compiler work, which well, it's going to wait until CodeGen for simple. I don't know if I'll ever get to doing the iterator cleanup. I did a bunch of that for Java iterators. It's a lot of work, actually. And Adrian saying, this is interesting. While loop predicates are in the same scope as the loop body. You mean when you say same scope, because they normally are for other languages as well, except that you can't put a declaration in the while loop. And occasionally that bites me. So Adrian, are you saying that you can add a declaration in a while loop? I got no sound from Adrian. Here's a sample case.
I just looked over my my IDE code, and it looks like most of my code is using like a traditional for loop, but that's because I'm doing a lot of lexing in it, and I don't need to parse the entire file or collection. So I, I should look at my other projects, but IDE, most of it is for loops, traditional for loops.
So there's some sort of predicate that I'm using where I want the predicate to return null or not. And the null means it's the end, no more, stop, whatever. But I want the predicate value if it's not null, but only in the body of the loop. So that would be a case where a while loop where you defined, where you created a variable that was scoped to while would be useful. And I hit this pattern. It happens every now and then. My sound is borked today. Okay, Adrian's sound is messed up, but I think we got the major gist of what you could do there. That's an interesting one as far as I am concerned, because again, for simple, that would be also very, very easy to go implement. It might be useful. And then the do while is the same issue. The do while one makes no sense to me that it's the normal way. So if I do a do while in simple, I'll do it with that scoping rule that whoever anonymous Loris is, because that's just so much the right thing to go do. Oh, it says Adrian now. And that makes a lot of sense to me. Now I might change to doing do whiles more often if I had that. Yeah.
Yeah, that was I wouldn't have done do while in ecstasy if I couldn't do that.
Right.
Because yes, without that, it kind of has very
there's like a huge suck thing. Do this initial thing and test at the bottom, but I computed something inside the body. That's the test.
Yeah.
Geez, of course I computed it in the body. What the hell? Fine. All right.
So XTC has this, but Java does not.
No.
You can't test in the body.
No.
Java doesn't. C doesn't.
C doesn't. Java copied C here, and it doesn't.
That's ridiculous. That's as bad as copying the operator precedence.
All right, because Adrian's sound is borked, I'm going to quote him here from chat. 70% of things people say is super hard to do in a compiler turns out to be trivial, and the 30% of trivial things turn out to require a PhD level amount of work to get right. Yes, I'll agree with that. One of the issues though is that in a compiler that you are writing all of it yourself, or there's a very small mental code base, you could do sort of big changes simply. If you went into LLVM and tried to hack do while lifetimes, I bet you'd have no end of issues in there. I suspect that would be quite the bitch to get it to work in LLVM.
Oh
You
no,
know
no,
what?
that would be Clang. That would be mostly Clang.
Oh,
They should out very early to something that is the same for anything, whether it's for while or do while. So I don't think it would be that hard because it's just something that you do in the front end.
so you could sugar it in Clang and life would go
Yeah,
on. I
yeah.
propose that somebody, not me, ought to do that and offer it as an alternative language spec.
Does make me wonder whether languages should spend their first 3 years with a single user who's also the developer to work out bugs before letting anyone else into the
Yes.
code base.
Yeah, eat your own dog food for a while before you let
But
it. It does turn into things that are kind of weird looking for other people that you're
yeah,
quite used to after 3 years.
just the common use case is that the common recommendation is that you should write a compiler in the language in that language, but the problem is that you get a language that is very good for a compiler writer, but not necessarily good for anyone else.
Yeah, yeah.
I'm actually using the Bolin runtime for my IDE. Like I copied like half of it, and I'm improving some of it, so I'm gonna backport it. But
You're about to say, right. Well, part of then
runtime,
is your job is
yeah.
to not copy and edit and have half used, is to make the Boolean runtime a library that you can just use directly as a separable project from the IDE. And that would be the necessary things you have to do to any runtime to make it usable in any context. So if it wasn't
That's
usable for the
actually
IDE directly, then you haven't got it right yet.
That's actually what I did the last 2 days. I just been pulling out some of my code, putting it into a library, and then testing it more,
Yeah.
and making sure it runs on multiple projects instead of just the two.
Yes, exactly.
It's been fun last 2 days.
Yeah, C2 came out in like 2.5 years, and the next 2.5 years are all spent hardening it.
I kind of wonder, like, this does not have to be specifically Clang or LLVM or GCC. I kind of wonder, like, you guys all know I don't like dependencies, but I kind of wonder if you have like 50 people working on something, if they kind of like have some kind of weird uh, like abstractions that like are over engineered and become its own dependency. Like I don't understand how you can have have a code base like that hard to change from what I understand. I from what I hear, all three of those are
All
very
right,
difficult to
sir,
change.
your job is to go get a job at a big ass company with a big old code base and try to do something useful without killing yourself.
I done that, but that's mostly because there's been like 200 developers on it, and no
Well,
one wants to refactor.
exactly. Every one of these big projects has the same problem. No one wants to refactor. I got away with it because the dominant programmer on C2 and it did a lot of refactoring and a lot of people bitched about it and I told them to stuff it on refactoring.
I
And,
thought that LVM is big on that.
it worked out well for me, but, or at least
And
somewhat well. Worked well in the very long run for it was a usable thing. I got,
LLVM actually
basically
broke me.
booted out of Sun because people couldn't handle me coding too fast and changing everything on them all the time.
It's unfortunate. I thought LLVM loves to refactor, and they broke me, so I'm a little upset about that.
There you go.
I mean, that's the thing. Google used to talk about there's two kinds of code base.
Yeah.
There's the stuff that is surfing. You are at the top of the wave, stuff is changing under you. You are going to have to continually update your code because it's breaking. And there's things you can do in those code bases that you can't do in a more static code base. And there was other pieces of the code that were described as pylons. This is a thing that has been driven deep into the ground where it cannot be moved, and you
Yes.
can build on it and know that it's not going to move on you, but you're not going to get anything new from it.
Yes.
And there was always this tension of like,
Yeah.
do you know which projects are pylons and which projects are surfing? And you need to know whether you've built on a surfing or whether you've built on pylons because
So
all-
is
you
it a
signed
mag-
up for very different problems in those two worlds.
all the Node.js things all were surfing all the time.
Is it the management thing that causes a project to be Pythons that's like very hard to work
No,
with?
it's not management. It's it does a useful thing. A bunch of people depend on it. And the reason it's not very mobile is because it exposed too much of itself so that you can't change, Hiram's law, you can't change anything because someone will break. And
Yeah.
that's typically because it got built fast in a hurry to do a very important job. And after it got built, everyone else piled on because it was doing such a wonderful thing, but it got built in a hurry. So there wasn't time to go factor it nicely and put in cool APIs and clean up how you dealt and whatever. And so it just, it can't be touched without breaking everybody who piled on.
I kind of wonder if code reuse causes things to not be fixable.
Okay, Adrian, why is Aaron a Protoss player?
Because he said pylons. And the Protoss are
Oh,
pylons.
fine.
Pylon
All right, I should
technology.
have known.
Yeah.
Pylon, but that was a Google term, right?
No, it's StarCraft term.
No, I didn't know that. I got the StarCraft reference.
It's also
But
a term for
Aaron
like
said he
building
came
a
from Google.
bridge.
Yeah. Where did you pull up Pylon? From Google using the term, or you pulled it out of your head because you're a Protoss player?
I got it from a senior technical lead at Google who was describing how to think
Okay.
about different pieces of infrastructure and the importance of knowing whether you're surfing or whether you're built on pylons.
So that Google senior engineer is probably the Protoss player.
Yes, maybe.
I think Adrian drank too much Vespine gas, but I need some more of it.
I'm sorry, you need what?
Vespine gas.
Oh, that's
Yeah.
so like not the Protoss, not the StarCraft players watching the video won't catch any of these references. I'm not a StarCraft player either, but I've watched some of the videos. They're kind of entertaining.
Every person in my school probably played that game, so I had to try it, and it's fun.
There you go. I have other things to talk about in simple if we want to go there,
Yeah.
which would be, can I find the,
And by the way, I like where you guys eventually ended up with the var and val, not just because it matches what we decided.
okay, so the other big thing that came out of simple was mutability. And here's the read up, which I'll just point things out. Primitives are always mutable, whether or not you love it or hate it. I know Matt didn't like that.
So I do disagree with your use of terminology, though, because
Okay.
you have, if I have x equals something, right? There is the identity x that refers to some, could be register, could be memory, whatever. And then in a system that has pointers or references or whatever, there's the thing that's pointed to.
Right.
And so, and this is where C++ ties itself into frickin' knots with const. And only Matt can tell us what it actually means, or Godbolt.
Well,
maybe.
I claim I'm trying to do something sensible there along those lines. Yes.
Right. So what I'm saying from a terminology point of view, I would pick an explicitly different word to mean I can change the contents of a variable versus I can change the contents of a, for lack of a better word, structure, object, thing.
Okay.
That's pointed to by a variable.
And you say change the jargon word, you mean don't use the word mutable.
Well, I'm saying be careful which words you use.
Well, okay.
You don't have to choose the same words that someone else chooses, but what I'm saying is be super explicit here, because when I say x equals hello, say in Java, right? I say x equals hello. Hello is immutable in theory. Of course, it's not, because we can unsafe it and whatever, but I mean, we can reflect.
Don't step outside reflection unsafe. It's immutable. Yes.
So x equals hello, but I can then say x equals world.
Yes.
So mutable
exactly right here. I'm explaining which mutable I mean.
So okay. It's the keywords that it's pointing. It's var x or
identifier.
val x.
You can say something like deep
So
or shallow
yeah,
immutability if you want to be precise. There
the,
is
the
that
identifier is
distinction.
useful. The identifier is reassignable to something else.
But
Okay.
generally, when you say X is immutable, you really do mean deep immutability because
Right.
it's X itself that you cannot mutate, including rebinding. I think you were looking for rebinding, Cameron.
Okay.
Whether you can
So
rebind or whether you can change the contents of what you are binding to.
so references are coming up where I'm
Zoom,
highlighted
can you
right
zoom
there,
a little
line
bit?
50. That
Zoom.
guy is the same. He has no deepness to him. So whether mutable means shallow or deep mutability is immaterial here. X is mutable, but there is no deepness to him.
Yeah, I mean, there is one thing. If you had int like integer in Java, you could still think of this as a binding, and then you could ask whether it is rebindable or not. And then you could say that if it's not, then it's deeply immutable. But I would personally stick with primitives, of course.
Right. So there's a distinction here of the choices I made versus just how explaining it.
Yeah, yeah.
And I'm looking for a wide audience, but a compiler aware, compiler smart audience. So that's the reason I'm going for mutable and I'm going explicitly examples here where I cover all the bases and talk about which is which and what is what. So here in struct S, so that struct is a structure. It's going to have memory. There'll be pointers to it. The pointer I'll call a reference, but it's a pointer. And then I make these four choices here. The first one is I've made an S field. The S is rebindable in Matt's term. It's reassignable. Also, S.x++ is allowed. It is deeply mutable.
Disagree.
I'm like making sure that it's clear in exposition, not choices of what the language ought to should it be. Do you disagree that my explanation was clear here, Cameron?
It confuses me, which is why I
Okay,
said this. So if I have x equals 42, I never mutate 42. I
that's correct.
rebind, to use Matt's terminology, I rebind it to a different immutable value, which is 43.
Yeah, I'm busy showing off rebinding here.
Can you
So you
Line
zoom?
want
50.
mutability and bindability to be different
Yeah.
terms.
So I don't have a good term for rebinding that I think is in widespread use. And the unfortunate term mutable does have this deep and shallow differences, so the two different things, and you have to pick it up from context. In the case of a primitive, which has no internal parts, it's the same thing, which I believe I can use, which is why I believe the word mutable is appropriate here,
But the point
because
is
there
that
is no deepness.
x is not a primitive. X is a holder of a primitive.
Fine.
So that's where the differentiation comes in. Matt's
Yeah.
terminology is good. I don't know if I would use it, but the so the holder is something I would say set. Matt would say bind.
So when I say primitive here, I don't mean
Yeah.
X as a primitive value. I mean X as the holder of a primitive. The primitive is
Yeah.
And
obviously
then
a value.
that Cameron is you are tied a little bit to reference semantics, but maybe not in the obvious way. So I'm thinking here in the terms of
True.
referential transparency, which means I can always substitute X for 42 itself. So when I read the code, I literally can think, when I see X, I can think of 42, and then I really would be mutating the 42 itself. So it depends on where you come from, what your background is. You probably are thinking in completely different terms.
Yeah. So I mean, we're definitely using reference semantics for everything. So you're spot on.
All right. So I don't know what to do here on line 50 that makes it
But
more
I think
clear.
if you're literally explaining this, then it's fine.
Yeah. I'm trying to show the language choice and build on what I would think would be a wide variety of people's
Yeah.
understanding of what goes on
You
here.
could, you know what, thinking out loud, you could just define what you mean by immutable very early on.
This is as early as it gets.
And I don't mean by defined by example, but pretty much just repeat the conversations we would have, that you refer to X, that you don't talk about just rebindability, that you talk about not being able to change the value through X, yada yada. So define literally in words first before you show the examples even.
Okay, in my experience, those explanations are horrific and they're only for language lawyers. I would happy to have that explanation come right after the example, but if I'm not a language lawyer, I'm not Gilad Braca, those explanations are, I need the example first. And then talk me through the example.
Yeah, I can see it both ways, to be honest. Yeah.
Fine.
Yeah, I
Okay.
really like examples.
I'd also like to take this moment to express gratitude to the language lawyers for making it possible to treat Java as pylons that aren't going to shift out from under me, and my old code still works.
Right. And then there, Adrian says, I prefer the examples first before the formal definitions. And you want the formal definition at some point. I don't have a lot of formal definition here. And I was actually hoping that as part of the code review, I would get some commentary on what to do about how formal you want to get. This is not the goal of this to be a super formal language, but I want it to be obvious what it does, which means there's a formal semantics somewhere.
Is it too soon for that, or do you need more code to be written in the language before it's a good idea to pin it down?
No, it doesn't pin down. You need the formal semantics. And you change the formal semantics when you change the language. Right? So there is a formal semantics. It's what the language does. Okay, what it does here is, I think, is pretty obvious. It just hasn't got a formalism written out per se. And then Cameron's terms for what these things mean, and my terms, which appear to be a little bit at odds. And so I want to come around to, what do other people say when they look at this? Here, my line 50 int x, in my head, that's very clearly x is holding a primitive. But I don't need to say that. I can just short and say it's a primitive, but it's x is holding a primitive. Yes. X is, as a holder is mutable. The primitive as a int 43 is clearly not. It's a value.
Yep.
All right. Then I get down to the then code at line 56 through 60.
Can you zoom a little bit because it's
I
really
probably can. I have to ask this guy. Does he have a view option for settings on viewing code here? Or do the browser blow up? Anyone know how to make the thing get bigger? I'll do the browser blow up. It'll just shrink the viewable space though.
Yeah.
I lied. Oh, no, it's going to do it. Okay, so it's very slow. Where did you go? Yeah, here we go. Is that better or more? Probably more.
If I can a little bit more. Yeah, that's probably
Okay, and I can't make the left-hand margin go away, but I can grow the right-hand margin. Let's see. You love to like hide the left. Can't be
I
done.
believe there's an icon under chapter 17 that will make that margin go away. Next to the open button.
Chapter 17?
Higher.
Higher?
Next to the open button.
I don't see an up here. Oh, here.
Does that not hide the side?
Thank you. All user interfaces are obvious, right?
Yeah.
Fine.
I don't even know how to computer.
Yeah, exactly. All right, so here we go. So one of the things that going on here is for primitives, and the concept of being an initialized or not makes a difference or doesn't. Whereas for a reference, if you are not initially initialized, I do give you an initial null. So my theory is you intend to be initialized. So the holder S is mutable. And I will also make it deeply mutable. So you can go through S to modify the field X within. And I can make X have an initial value, which I will use later to make it immutable. It's initialized in the constructor. It'll be immutable by default. But here, because you have a mutable S, it's deeply mutable. It can modify X anyhow.
So when you just say new S,
Uh-huh.
my guess of what that would have meant was call the zero argument constructor,
Yes.
but it's not. It's just give you a null.
No, it gives you, when I say new S, it gives you the zero argument constructor, just like
Okay.
you guessed. That is the zero argument constructor, which is by default, all fields are filled in with the normal initial value for fields, which is usually a flavor of zero. Okay. Here, since I've defined on line 59, define S with an initializer, I'm going to say it starts life as the holder S is immutable and also it's deeply immutable. I cannot call S.x++. And whether or not the internals of S get a constructor and they have initial values or the default doesn't matter. The fact that S itself is made with an initializer means it's deeply immutable.
That will be a little surprising to users, maybe.
Well, this is a design choice now that's interesting.
Yes.
Once we're past the jargon here, this is the interesting design choice. And my theory here is if I give you an initial value, that's the value I intended. I'm writing functional programming style. You got that value. It's immutable now. That's the intent.
So if I want a mutable thing, but not a nullable thing,
Yeah.
can I express that?
Yeah. So if you want a mutable thing, I'm sorry, you want
Because
an
your S
immutable.
space S creates a null version of it that then gets populated.
Yes. So this means S here, the
Right.
little s is clearly a nullable value. It starts at null. It has to be
It's
null.
clearly, yeah, it's clearly a mutable nullable.
Yes.
If I want a mutable not nullable, can I?
Yeah. This line 62, the very next line down. The bang makes it mutable. It was not given a null, so its starting value will not be null. It didn't say S question mark. So it's
Okay.
not nullable, but it is mutable. The question
Okay.
mark's handled in earlier chapters, but it applies here. If you don't have a question mark, you're not nullable. And the
Except on
language
57.
for people who care, the language does not allow you to throw a null pointer exception under any situation. It will fail to compile if it's possible to have a null pointer exception. And you just put a null
So
check in.
why does 57 not have to be S question mark S?
We could go back and forth on that. I could demand that it requires a question mark there, that it's not allowed to say mutable without the null.
If you're implying that it's nullable,
Yeah, you're implying it's nullable by lack of an initial assignment, but I could argue that you have to have it. Now, in constructors, the definition of a language might be one that is not nullable, but I don't have it till I run the constructor, and the constructor has to set it. So I will have the syntax of S of no question mark S inside some other constructor, inside others definition, and then later in life assign it construction time. And I really mean for it to be never nullable or not. So there is a meaning here to this guy. I mean, you can get the other case of this, I guess. I should have an example. I may have an example coming up. Prior chapters have examples of that one, which maybe make sense here. There is a case where you'll have to put the question mark in. Here I can infer it correctly, but I can demand it for consistency reasons. It's fine.
does your syntax ever indicate whether something is a value or has identity?
Yeah, well, it's immutable or not.
So if I make an SA and an SB, and then I say SA equals SB, how do I know whether I'm comparing pointers and saying they're not equal, or I'm comparing values and saying they are?
I'm very clearly running reference semantics. So it has an SA is equal to some new S, and I say an SB is equal to an A. That copies the pointer. It's not value semantics, it's reference semantics. So it's pointer sharing.
Right, but if I say SB equals new S,
yeah,
and now they're identical because they're both whatever comes out of the default constructor, does A equal B?
They will fail a pointer check. There is no built-in fancy equals. This is a
Okay, so
pointer
if you
check.
want value equals, you write it yourself.
Yeah. So we could argue, this was always false because it's two different allocations. So at some point in life, you need an equals. You would say, I have defined struct S with an equals,
S
whatever.
dot A
Yeah.
dot equal B.
And he has an equals as a function that does something. And then you have to call A dot equals. Yeah. You would do this. And now, there's another option that says the double equals calls dot equals, and I'm opposed to that version. If you make a function call, you make a function call. And the reason for that is so I understand the local semantics. If I see a function call, I have to go chase it down. If I see an operator, I want to know that it's either not overloaded, or if there's overloading, you have added it. AA says you can overload. So I can go with overloaded operators, and I can make S have an overload on double equals that calls dot equals. But the
Okay,
default
so does
is
this imply that every object has identity, whether it's mutable or not, and there's no way to sort of disavow identity?
That's correct. There's a
Okay.
pointer under the hood. The hardware does a pointer, and you're going to live with the hardware having a pointer. The other option is I just say, hey, your equals according to some arbitrary function which computes Fermat's last theorem and takes the infinite amount of time. I have a function that's equal. How long does that take? Clock cycle or a billion years, I can't tell. And I don't even know unless I go hunt down what does equals mean. So when do you have to go hunt it down? Well, I claim I hunt it down when I see a function call. That's my long-standing theory that has worked well for C, C++, and Java for the last 40, 50 years. Also, I would just shorten the equals if I'm going to use it a lot to EQ. I think that's pretty clear.
I mean, at some point you have to decide whether this EQ is a standardized construct, so it can be a pylon that other code can rely on.
Yeah.
Because right now, if you can have a choice for the user whether they write equals or EQ,
Yeah.
then now you have completely disabled the ability to write generic algorithms.
Yes.
Like if you want to have a function find that uses equals comparison,
Yeah.
it has to work for primitive ints and it has to work for the structures. You have to have one protocol.
Right. And so what I'm saying here for simple, the language, that is not a key component of the language. That is not an important.
Yeah. For a teaching language, it makes sense, but I'm touching that for a real language.
In the land of AA, I've said you get in this case for equals, you would get interface or duck typing. If you have a dot equals, you can call find. Alternatively, if you call find with an S and an element here, it's going to require this will fail to compile because S does not have a dot equals, or it will, or it'll compile with a dot equals, and you get an interface. So find will demand that S supports the equals operator. And then you just put out some obvious terms or names for things that people would expect. If your library uses .eq for hashing and find in a couple other places, if people want to use the library, they'll add an equal operator. They don't have to, but if they want to, they can, right? So this is solvable with a more complicated type system without adding a lot of overhead, which it's out of scope for simple. So reference, pointers, identity, these things are not new. Two new S's don't have to be equals anyhow, because just because I give you the 0R constructor doesn't mean you didn't have other construction behaviors going on that made you unique. So the S's internally could just have a unique counter they bump up. And so I can't tell you that these are going to be reference equality, or sorry, deeply equals immediately. Anyhow, you have to call some sort of concept of what deeply equals means. And I find the compare all fields by default deeply equals to be occasionally useful, but maybe it's systems versus application programming again.
Well, it's reliant on whether you have generic programming support or not. If you have generic programming support, you need to be able to write algorithms in terms of something uniquely defined. So once you have the double equals for integers, then that's it. You have to have double equals for everything else. Or you would have to write different versions
Or
of
I have to
functions
have
of for
primitive
everything else.
versus not primitives. Yeah, well,
But
the
yeah,
other
but
one.
then it's not generic anymore. I mean, generic
Oh,
But
yeah,
means
there
totally
are
generic.
fine.
things
Generic.
for which I want value equals. Value equals feels very natural to me for integers or complexes or strings.
Yeah. Yeah, for small structures that have that are not deep or deeply mutable. They're
Right.
small, relatively small. So complex has two parts. Strings can get quite large, obviously, but they're typically conceptually shallow. They don't have any mutable subparts for sure. Um,
Right. So to me, the ability to say, hey, I've got a bunch of complex
yeah,
numbers. People can just make up their own complex numbers using complex literals or
yeah,
whatever.
right.
And I want them to just be equal. Like
Yeah,
the ability to have some kind of value struct in my language where I've disavowed identity and said the only thing that equals means is they are the same byte pattern on memory.
right. So my claim for simple here is no, because that implies a huge amount of runtime work and or typing work. And in other places, yeah. Although I would claim I want to know whether I'm paying for that equals call or not. What's the cost model for my head? Hey, it's all free. No, it's not all free. And so many times I have gone and fixed other people's non-free performance problems by fixing their concept of free.
Do you guys do array sequence equals a lot? Because I do it for testing, but outside of that, I don't think I ever do
What
it.
is array sequence equals?
I have a list of points and another list of points
Yeah,
equals equals.
yeah, array equals. These two
Okay, so
arrays are
maybe
equals.
maybe I'm just not remembering what it's called, or maybe it's a
Yeah,
C sharp thing. But you
I
just give it two arrays
yeah,
or two things that look like arrays,
yeah.
and it will iterate through them and compare them.
Right. I occasionally do that. It's rare, but it happens.
Like outside
So
of tests, you'll do it.
it's
Yeah.
not
I
it's
mean,
not a thing that I would put a lot of effort in the language spec for because of the number of times I use it is so low that I can just handwrite them when it rarely shows up. And in Java, I call array dot equals as a library call given to arrays are the equals. Okay, fine.
yeah, like set equals, list
Yeah,
equals, array equals. They're
right.
fairly
Almost
common
never
things.
use list equals because I don't use lists.
You know what? I actually do set equals as often as I use sets, I think.
Right.
Yeah.
Right. So Adrian's saying I do a bunch of these. I have an example where the arrays are of 8 bytes, which I would claim is a different thing where I'm trying to do a software as a whatever, SIMD in a register, which I'm not doing very often. Um, certainly in
There
the
is
land
actually
of,
a controversy of what should double equals mean for SIMD types, because there are actually two choices. Again, either you want to, if you compare SIMD registers, either you want to do the all reduction or not. And oftentimes for SIMD programming, you actually want a bit mask. So that's the point when you actually don't want the equals to return a single Boolean value because you want to actually use this bit mask all over the place in your SIMD algorithm. And it would
right,
really suck if you were to lose that information by the
right,
implicit reduction happening on equality comparison.
right. Well, that was my theory on the equals equals is known to be fast, implemented directly in hardware, gives you a single quick answer. And if you wanted some other kind of equals, you made a function call,
Well, I
and then you
mean
get to pick what equals meant to you.
that's the funny case. You will have a fast answer, but it's not gonna be single, right? Because it's gonna be a
Right,
vector of bit mask. So
right,
that's
right.
what the hardware gives you. But now the question is, do you want to follow equals equals always what the hardware gives you? Because if you do, then equals equals for SIMD vectors has to be a SIMD vector with a bit mask, because that's what the hardware gives you. No choice there. No, no ifs, no buts. You said you want what the hardware gives you.
no, it's the
Or if you want hidden costs by implicitly reducing this to a single boolean under the covers, and then you are hiding the hidden cost from the programmer behind your equals equals operator. But you just said you don't want that, so It's annoying.
Well, I would
It's
claim
annoying edge case, but it is
yeah, I'd claim
important.
very much edge case. I would also claim that SIMD values in my head are already structured values.
But
Um,
if that's like zero overhead sugar, then no problem. But if you think about this, it really is a register. It's as primitive as an int. And support for vectors really shouldn't be special taste if you are going for the close to the hardware language.
yeah,
Right,
no,
right now, my feeling is if I'm doing SIMD, I want to use intrinsics because I don't want any surprises with
yeah,
optimizations
right,
or it
right,
like hiding things from me.
right.
Because I'd rather not it try to emulate some kind of function when I could just change the algorithm ever so slightly
So
to
that I think is the third. That I think it is the third position. No surprises position. That really, if you are honest, that implies you want compiler error on anyone using equals equals on SIMD
yeah.
registers.
Yeah.
So it should
For
be
SIMD,
undefined compiler error period. But then you have just killed generic programming with SIMD. Because
Well,
now you
okay.
cannot write a single generic function that is going to use equality comparison for anything.
I think there's the
There are only trade-offs. I mean, I don't think anyone is
right. Well,
ideal
that
here.
implies that I have SIMD as a known primitive in the language because that's a parser issue. And as soon
see
as I say
SIMD.
my SIMD is not a primitive in the language, it's constructed in the language, then I don't have this question. And equal equals
Yes and
can,
no, because even if you allow now fancy library types and operator overloading, then you still have a question, should my operator equals equals always
yeah,
return bool or be allowed to return something else like a vector of a SIMD?
as soon as I allow operator overloading, the assumption is the library writer writing the overload is going to tell me what equal equals means.
Okay, so you don't even require the Boolean return type on equal equal.
No,
Fair enough.
no.
That's
If
a
it's an
choice, yeah.
operator, now if you're going to, if with a more complicated typing system, you can have all kind of bizarre things come out of that, and the compiler will just complain at you if you use a non-Boolean, vector Booleans in a Boolean position. Okay, fine. But if you just demanded it had a Boolean for equal equals, the uh, the library writer can still return a Boolean, and he just won't be using equal equals to mean bitwise compare. He'll have to give you a different operator for give me the bitwise pile of these things
See,
because the
I've been
equals has to be a Boolean, and I'm either going to turn you the zeroth one, or I'm going to do an and over all things, or I'm going to give you some operator overloaded equal equals that returns a bool if I demanded a bool there. But mm,
I think a SIMD is like tough enough that you would probably want to use the library to like hide it from you or
yeah,
to do most of your functionalities.
right.
But
Yes and
if I'm
no.
handwriting it, I want to no surprises and I want to the exact
Yeah.
intrinsics.
All
And
right.
I have to say, some languages are doing this fairly well. Like C Sharp actually is not looking that bad for SIMD right now for something that is useful for general purpose number crunching programmer. It's not that bad.
All right,
Surprising.
I'm going to look at mutability a little bit longer, and then we'll call it done for the day. If I can go find where my mutability is.
So we conclude we have going with var and val because Cliff is a huge fan of Scala, right?
No, I hate Scala. Not hate. I'm just not very fond of Scala. I just grabbed var and val because I've seen the names a lot.
Ecstasy.
You could certainly, and it's not nothing to do with ecstasy for sure, but you could talk me
Well,
easily
and
into
Ecstasy
calling
uses
it.
var and var because Cameron is a huge fan of Scala, of course.
Yeah, there you go.
I've read the books.
So var and val can be talked out of. Like somebody was saying, Matt was saying, use mute for mutable instead of var.
Yeah, I don't feel strongly about this, to be honest. I mean, var and val works for me too.
They do have the problem that
Mute works too.
they're one character difference, so it's easier to misread.
Yeah, maybe mute is a little bit
No,
standing out. Not sure if
no.
it's a big deal, but well,
No,
Theodore, you are
Theodore.
biased.
Yeah, yeah.
You want mutable, or you want mut M-U-T, or you
No,
want
no. Var and var. Var and var.
var and val. Okay, I have
Because
more
Scala
votes for
does
var
it,
and
right?
val.
They took the val from not OCaml, but something like that. Maybe OCaml.
Well, I'm using it to mean this, and I'm looking for ease of understanding in a tutorial and not
Model.
necessarily history. where it came from.
Yeah, at least to me, because of course I'm biased, but var and val are good.
So the next thing I'm going to show out here is what deeply immutable means, because it's through the reference that you have in your hand. So here I make a bar. The bar is the holder for the bar, to use Cameron's term, is mutable. And because it's mutable, I go inside and I mutate it. I don't know, line 84. I go look at line 86. I make a foo. It has a mutable bar inside of it and some other fields which don't really matter. And I go ahead and fill it in. And because it has a mutable bar internally, I can go through the bar and go set it, or go through and there's a semicolon missing here. There's a typo in the README. And then go through foo.bar to bar's internal fields and mutate them. But then the trick comes here where I say value x foo, and that throws away the mutability that I have with foo. And I cannot peek through foo any number of layers and mutate anything. I can read, I cannot write. So here's the
line
reading.
70.
That's like a boring immutable reference.
What does
Yes.
line 76 mean? Because I get very confused starting there.
Line 76?
Yeah.
Okay.
References with an initializer
Maybe
are
reference
deeply...
types. Yeah.
Reference types, reference
reference
holders,
types.
pointer types, pointer variables. What do you want to call a
I would
holder?
say
You're calling a
reference
holder. It's a
type.
funny word for me.
Reference
what-
semantic variables, maybe.
References.
This is
But
like,
I wouldn't say just references either. Yeah, I agree. It's a
So
bit
do you mean
strange.
initialized variables cannot be...
Even variables with an initializer,
okay,
right?
yeah, initialized variables are by default deeply immutable.
Yeah, why not? That doesn't seem bad.
So
Okay.
by deeply immutable, you mean that the variable can't be changed and the thing that the variable refers to cannot be changed?
Yes. No,
Yeah,
careful
but
here. That's exactly explaining here. The variable cannot be changed because it was initialized. It's deeply immutable, the variable is. You cannot use that variable to mutate things deep inside.
Huh.
But
when
you can
I
have a
look-
mutable version to
that
the
is
same.
that does seem too much as deeply demutable. I mean, when you think deeply versus shallow, that's it, right? I mean, you couldn't define it anywhere else, any other way.
So
It's just like deep copy versus shallow copy. I mean,
Yeah, exactly.
either you think about the binding itself, what it points to, and the pointer, or you think about the contents.
Right.
And
I am tying together, in order to have less syntax in the language, I'm tying together whether or not you're deeply mutable with whether or not the local variable, the holder, is mutable. And you can exclude one or the other by using the bang operator to make a obviously, oops, I'm doing something special here. But outside the bang, or var is variable already as well. And var replaces your type.
and that's why I didn't understand line 78, because you said var.
var works for var as var is already described by line 65. Var is variable. This happens in a prior chapter as well. So I'm building on a prior chapter. Var means variable. I think it happened in a prior chapter. When did I bring var in the first place? Oh, it might just be here and might need more references to it. No, it's earlier in this README. It's just above here, var and val.
Yeah.
So you get the type from the expression, but the mutability is inferred to be variable, mutable. So down here, when I'm looking at var and val in this section here, this means I've initialized S. So it's a holder, holds a pointer to a capital S. It's variable. I can change S and I can mutate through it. Or it's not, it's for variable. See, this is supposed to be mutable. Oh, there's another bug in the README. I can't
Yeah,
edit.
that's why I was confused. It sounded
Yes, this
like
should be
the
value. You're
opposite.
correct.
Okay.
Yes, value is. I meant this right.
So
So okay, so
77
this is
should
why I
say
want.
val.
This is why I want a code review. Yes, that is broken there. I
Okay,
even
so
remember
77 and 78 should both say val.
it should say both. Yes, they should both say val because you're initialized. The assumption
Right.
is you got
And
it
then down
right. You're not
below on
changing.
87, you should put a comment that you could also have said var in addition to foo bang foo. You could say var
Yeah.
foo equals
Yeah. Okay.
some, and that would, things like that would tie it together a lot better for me. Var foo
Uh,
equals
Foo is equal
new foo.
to da, 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 da. Add a comment. I don't know what adds a review means. How do I not have this here?
Change, yeah, to val. Right.
Okay. Now it's hard to read because these things are inlined. But fine. Here I have a semicolon missing. Let's ignore that. All right, is the rest of it now understandable here? You like this. Hang on, let me do this one too. Let me go edit this guy. I have to make another one? I can't edit? How do you edit? Edit. Thank you. References with an initializer. Something.
Or initialized variables. Yeah, initialized variables.
Yeah. Yeah.
As a note, you could actually consider calling this binding, depending on whether you assume programming languages background or not. So in programming language semantics, like in Peirce's book, Types and Programming Languages, when he introduces let bindings for the first time, he does make the definition of what a binding is, that it's basically just a way of associating names to something, like to expressions, for example. When you want to give a sub-expression a name, then that's a binding. And this binding is just binding some identifier to some value. And you don't have to talk about variable or not. And that kind of takes away the whole argument. You can often see functional programming language programmers make fun of the use of word variable, because variable is something that shouldn't vary.
Yes.
If you think about it, but binding kind of makes sense. But I don't know, if people who know programming language semantics will know this word binding. People who do not may or may not. I'm not sure.
Well, I'm trying to target other compiler writing thinking people.
Yeah.
So they have to have some language semantics.
There may be
The-
some overlap, but it's not exactly. This one is really
That's why
compiler writing, the other one is programming language formalization, and there is an overlap, but it's not a perfect circle.
Uh-huh.
that's why I wrote for identifier because
Well,
the
identifier is something in the
Thanks, Cameron.
grammar. Binding is something in the semantics. It's
no.
not the same level.
So if but
It's not the same level of
it's
abstraction.
not
I know
arguable,
what
but
you mean.
I would interpret it in identifier as something that you can reference to. It's something that can be identified in the
Yeah,
form.
but identifier is also a name of a function, and I'm not sure if it's even allowed here to redefine
The name of the
the-
function is also identifier.
Yeah,
So,
yeah, but I don't think you can rebind it here.
so the identification and rebinding they do not need to be the same thing. So
Yes.
Where did functions come into this?
so Matt says that when you name something identifier, it also means the notion of rebinding, but that's need
No,
not
no, no, no,
that
no. I'm really just saying that identifier is something that is already comes in the language grammar. That's all I'm saying. And
yes.
identifiers are then used for things like variable names, function names, module names, class names. A lot of things are identifiers.
Yes,
I
yes, yes,
wonder if it's appropriate. I don't know. I'm just thinking out loud, but I wonder whether it's all appropriate to call all identifiers bindings, which
yes,
I think is
yes,
what you seem to be implying. I'm not sure.
yes,
Maybe.
because they become handles how you refer them in your program, and they
I
use
would
them.
not use the word handle because that's not something that is
That means
defined
something
in.
else. Yeah, I know.
Yeah. It's not
It's
defined
something
in
we always
tuple.
have.
Let's stay with
Fine.
tuple terminology.
Okay, cool.
But
Because we're just gonna have circular arguments when you say it's something like a handle, and then you have to define handle, and then you can say a handle is something like an identifier. Then you see my problem with that.
yeah.
I
Okay,
mean,
okay, fine. Let's
it's
call
not
them
a definition.
they identify something in your program. That's it.
Yeah, there's
Identifier is something you can literally define in the grammar when you define what alphanumeric characters it can comprise. I mean, you have defined this very clearly.
That's
Binding is something you define when you define language semantics. You start to talk about the evaluation, then you talk about
right.
expressions, values, and then you want to bind those values to something. And
the
yes, I agree that at some point it may collapse again. But
you
you see,
can
when you are defining, just think of defining programming language from zero, starting from the scratch. And suppose you are starting from the language grammar. On day zero, you may have defined what an identifier is. But it may take you a bit more time to even get to the point when you can start talking about defining bindings. It's just chronologically, you don't do those things at the same time if you start from zero.
okay.
Maybe it doesn't matter. Maybe it still
They,
reduces to the same thing. I'm just thinking out loud.
yes, yes, yes. They are tangent concept. They almost mean the same things and almost not mean the same thing in different concepts. But for the purpose of the tutorial and the README,
I
so
disagree very strongly. When you have two terms that are similar and they mean almost the same thing, that's all the more important, especially in tutorial for new people, to make very precise and clear and exact distinction. So I am
on
pretty much black and white
on
opposite
the
on this.
contrary, if the programmer is new, then he won't be able to clink these concepts right away.
But that's the problem. Then you will confuse them forever because they don't even know they don't know. So they
No.
won't even know to Google for those things. So it's better to use official terms that are at least defined in books because they can search for them and then they can find out. But if you start using those interchangeably, then you're kind of screwing them forever because they cannot even Google for that thing because they don't know it's something they should be Googled for. I think I would err on the side of being exact and precise.
Okay. Okay.
Just to give people a chance to find out that maybe there's something they should Google for.
Mhm. Okay. That's okay.
Yeah, I'm trying to decide if I'm going to change or add a section in it's just like a deep slippery slope to head down the what's it mean to be a variable, a value, or a let binding or anything like that
Yeah.
here.
Hmm.
And it's
At most, I think all I can do is add a leading section. If you're interested about these things, go Google them.
can I add a side note? There's this nice book, Crafting Interpreters, that is using those side notes very effectively when he wants to put something out of the main text that is a detail. And so that can be an effective
Okay.
way.
I got one more thing here from Jim, and then I'm going to bail. What were you trying to say in the chat here, Jim? Are you on? Can you hear?
Yeah, sorry. Bringing up the let assignment of value, I was just sharing the Kotlin function for let, which does the job.
You have a function in Kotlin called let. Not to be
It's
confused
yeah,
with
it's part of the standard library, but the standard library has a lot of little Kotlin inlines like let to do block operations that kind of make the language.
okay. Because like
So
the usual meaning for let is it's a syntactic thing, so it cannot be a library. It can only be a syntax that means some mathematical thing.
sure, yeah, Kotlin has the object.let syntax for block, which then the option is to remove the parentheses around the lambda inside to make it look like a functional keyword, sort of.
Okay. Okay. Yeah, I don't want to go down the deep meaning of let versus variable declaration. and the recursive use of polymorphic variables and stuff like that. And
By the way, just to recall a simple example of the difference between identifier and binding. Identifier could be a valid identifier name, like a variable name. Binding could be also an operator plus. We could bind operator plus to do addition on integers. So you can bind operator plus to do addition on matrices. It's
Yeah.
still a binding, but plus it may not be a valid identifier in
I
your
see what you're
grammar.
saying.
So binding, it's not an identifier, and identifier is not binding when you have distinctions like that.
Yes, I do this operator overloading thing, and I turn the operators into valid identifiers, but they show up in
Right.
in order positions in expressions, so they're not normally part of the
And even that is
special
it is
treatment.
it is useful to be able to say that I turn
Yeah.
operators into valid identifiers. That's something that is useful to be able to say.
Yeah. All right. I think we've run this guy down. Boy, it got very exciting here at the end when people were like, "Oh my God, reference or not, or this or that." And for loops, people are excited on the container version of for loops. Somebody want to go implement the container version of for loops? I'll take it. When I get when I get a larger semantic collection thing, the container makes a lot more sense. Right now, containers would only be for arrays.
And of course, that would drag something like generics into the whole thing.
Right,
Because the
yes, and
moment
then
you
I don't want
start
to get
talking
into
about
generics here.
collections,
Right.
yeah.
Yeah, and I don't want to do generics. I don't want to do Hindley-Milner typing. There's a lot of fancy things I don't want to do. Fine. Okay, then I'm going to claim done.
So this will have to wait for simple plus plus.
That's right. That's right. That was entertaining. All right. I'll hope to see people next week.
Yeah, have a good weekend.
All right. Bye-bye.
I